NASA's Voyager 1 spacecraft holds the title of the farthest traveled object ever built by humans, having exited the solar system and ventured into interstellar space. Launched in 1977, Voyager 1 continues to exceed all expectations decades after its departure, sending back invaluable data despite being crafted using technology that predates today's digital era. The story of Voyager 1, along with its twin, Voyager 2, stands as a symbol of scientific excellence and human perseverance. What was initially designed to be a relatively brief journey to Jupiter and Saturn turned into one of the most successful and far-reaching missions in the annals of space history. The original intent was a 4-year mission to study the two gas giants. But thanks to the foresight of NASA's Jet Propulsion Laboratory engineer Gary Flandreau, that plan expanded dramatically. During the late 1970s and early 1980s, a rare planetary alignment occurred, an event that happens roughly once every 176 years. This alignment allowed spacecraft to use gravitational forces from the planets as slingshots, enabling them to increase speed and alter direction without consuming extra fuel. Through this gravity assist method, the time required to reach the distant planets was drastically reduced from 30 years to just over a decade. Capitalizing on this limited time opportunity, NASA launched the twin probes within weeks of each other in the summer of 1977. Few could have anticipated the impact these spacecraft would have on science and society. Now, more than 45 years later, both continue to transmit data from the furthest reaches of the solar system and beyond. Though roughly the size of a small car, the Voyager probes have made an immense impact on space exploration. Their early missions provided unprecedented views of the outer planets. Voyager 1 captured breathtaking images of Jupiter and Saturn and revealed geological activity on Jupiter's moon Io, making it the first observed volcano outside Earth. Voyager 2 followed a different path, making it the only human-made object to fly past both Uranus in 1986 and Neptune in 1989. These flybys uncovered critical information about magnetic fields, weather systems, and moon formations around these distant giants, transforming what was once speculation into concrete scientific understanding. Their mission was not without obstacles. Both spacecraft had to survive the treacherous asteroid belt and the icy vacuum of deep space. Each was built with only 69 kilobytes of memory and relied on analog tape recorders to store data. Communications are powered by 23-watt radios, no more powerful than a standard household bulb. Receiving their faint signals requires giant 12-meter radio dishes on Earth, and even then, it now takes over 18 hours for a message from Voyager 1 to reach our planet. The defining moment in Voyager 1's journey came on August 25, 2012, when it entered interstellar space, becoming the first human object to do so. Voyager 2 followed on November 5, 2018. These milestones marked humanity's first steps into the space between stars, outside the heliosphere, the protective bubble created by solar wind and magnetic fields. Scientists had anticipated specific changes as the probes left the solar bubble, particularly a spike in cosmic rays and a noticeable shift in magnetic field direction. Surprisingly, while Voyager 1 detected a significant rise in plasma density, the magnetic orientation remained the same. This unexpected result caused scientists to rethink long-standing theories about the structure and boundary of the heliopause. This region, once thought to be a sharp cutoff, is now believed to be more complex and dynamic, consisting of layers and turbulence. Voyager's ongoing readings continue to refine our models of how the solar system transitions into the broader galaxy. These groundbreaking insights opened a new frontier in astrophysics. Still ahead of the spacecraft lies the Oort cloud, a distant, theoretical shell of icy objects believed to encircle the solar system. Though Voyager 1 and 2 won't reach this region for thousands of years, they are steadily moving toward it. Their journey through this mysterious outer region remains a long-term scientific curiosity. Despite being over 14 billion miles away, Voyager 1 remains a critical tool for understanding interstellar phenomena. It collects and sends back data on cosmic rays, magnetic fields, and solar wind patterns, giving scientists a rare window into the conditions far beyond the planets. But the Voyagers are more than just instruments of science. Each carries a golden record, a gold-plated copper disc designed to serve as a time capsule for alien civilizations. This disc includes greetings in 55 languages, natural Earth sounds like ocean waves and thunderstorms, and a wide variety of music from different eras and cultures, from Bach to folk songs. Alongside these audio recordings are images depicting life on Earth, ranging from mathematical formulas and anatomical drawings to pictures of human life, animals, and nature. The Golden Record was a bold attempt to encapsulate human civilization and send a message of peace and unity into the cosmos. Should another intelligent race encounter it, they may gain insight into who we were and what we valued. In that way, the Voyager probes serve dual roles. They are both scientific pioneers and cultural ambassadors. They carry with them humanity's curiosity, creativity, and desire to connect beyond our world. What makes this achievement even more impressive is the age and limitations of the technology. Built before personal computers and modern smartphones, the spacecraft operate with minimal memory and power. Engineers continue to innovate with limited resources, turning off non-essential systems to conserve energy while ensuring data transmission continues. Even now, the mission control team finds ways to maintain contact with these distant travelers. Although only a few instruments remain active, the spacecraft still collect vital information, helping researchers improve their understanding of how our solar system interacts with the galactic environment. The cultural and scientific impact of the Voyager program is immeasurable. Its findings have reshaped planetary science, inspired books and films, and sparked the imaginations of millions. One of its most poignant contributions came in 1990 when Voyager 1 took a photograph of Earth from more than 3.7 billion miles away. At Carl Sagan's suggestion, the spacecraft turned its camera back toward home and snapped a photo now famously known as the pale blue dot. In this image, Earth appears as a tiny speck suspended in a sunbeam, a fragile island in the vast ocean of space. That photo, and Sagan's reflections on it, serve as a powerful reminder of our unity and responsibility to cherish our planet. As decades pass, the Voyager spacecraft continue to demonstrate the boundless potential of human ingenuity. What began as a modest planetary mission has become a historic odyssey into the unknown. The success of these spacecraft proves what is possible when vision, science, and perseverance come together. The alignment of planets in the 1970s was more than a rare celestial event. It was the key that unlocked the Voyager mission's success. Each gravitational assist allowed the probes to gain not just speed, but the opportunity to reach and study distant planets. Without these boosts, Voyager 2's visits to Uranus and Neptune would never have happened. And the insights gained from these encounters were staggering. Voyager 2 revealed Uranus' off-kilter magnetic field and Neptune's extreme weather, including the fastest winds recorded in the solar system. These discoveries fundamentally changed how scientists viewed the ice giants. Despite their outdated components, the Voyagers persist. Most of their original systems have been powered down, yet they continue to provide real-time data about regions no other spacecraft has explored. Their slow, steady drift through the interstellar void is like a solitary voyage across an alien ocean, a realm dark, vast, and largely unknown. When Voyager 1 entered interstellar space in 2012, it encountered a starkly different environment, filled with denser plasma and unfamiliar galactic forces. Its instruments registered elevated levels of energetic particles and cosmic rays. However, the predicted shift in magnetic field orientation did not happen, challenging earlier assumptions about the heliopause. This boundary region, it turns out, is more chaotic and layered than once believed. Rather than a clean division, the shift from the solar system to interstellar space is gradual and complex. Voyager 1's data gave researchers a first-hand look at this turbulent frontier, providing a treasure trove of information that continues to reshape our cosmic understanding. The significance of this exploration extends beyond data and diagrams. The knowledge that these small probes, powered by radioisotope thermoelectric generators and guided by 1970s-era code, continue to send us messages from the edge of the solar system is humbling. It reminds us of how far our curiosity can take us. The zone where solar influence fades and galactic conditions take over remains a subject of active research. Thanks to the Voyagers, scientists are now studying this transitional area with greater clarity, piecing together how solar and interstellar forces interact. Beyond science, the emotional and philosophical weight of the Voyager mission is profound. The notion that these two spacecraft may drift through the galaxy for billions of years, long after human civilization has vanished, gives them an almost legendary status. They are time travelers, carrying the hopes and legacy of Earth across the cosmos. The golden records, still intact and traveling through space, serve as humanity's message in a bottle. They may never be found, or they may one day be discovered by another form of life. Either outcome underscores the optimism and adventurous spirit that drove their creation. In every sense, the Voyager mission exemplifies the best of what humanity can achieve. From a humble start as a mission to observe Jupiter and Saturn, it evolved into a journey of cosmic proportions. The spacecraft continue to provide valuable scientific data and symbolic significance, proving that with determination and vision, even the simplest goals can lead to extraordinary accomplishments. The Voyagers are more than machines. They are our emissaries to the stars. They continue to teach us not only about distant worlds and interstellar space, but also about ourselves, our ingenuity, our desire to explore, and our relentless pursuit of knowledge. As long as they journey onward, they remind us of the boundless potential that lies within the human spirit.